Ew, what's that negative 1 doing right there? Oh, that means it's an inverse. Okay, this means it's the inverse of g. It's the opposite. So like, if you were to, theoretically, if you were to plug a 1 into g and that gave you a 2, then you could plug a 2 into g inverse and get a 1. Like it does the opposite, theoretically. Okay, but I don't know if I get a 2 if I plug in a 1. But anyways, so we got to find the opposite function for this guy. In order to find the opposite function for that guy, I'm going to take out the g and put a y so he's easier to work with. Now, you don't have to do it this way, but you can do it this way. I'm going to switch the x's with the y's, or the y. So I'm going to have x right here equals negative y minus 2, and then I have a y plus 4 on the bottom. And my goal here, Stews, is to get the y alone on one side. And then that would be the g inverse. Oh. Okay, so first, kill the fraction. How do I get rid of this fraction, Stews? Damn it. Multiply both sides by?
Y plus 4.
Y plus 4. Hey, this is kind of like when I was solving and I had to do that. You're right. Kind of is like that. We're learning how to manipulate equations. So on the left side, we get y, or xy, plus 4x. On the right side, they died. Negative y minus 2. Okay, now this is the part where you foos get lost. Okay, so this is what you have to do. You got to get the y terms on the same side. The y terms on the same side, and get everybody else out of there. Okay, because we're going to do some factoring. So here's a y term, and this is a y term. We got to get those guys on the same side. So I'm going to add y to both sides. Here, I'm going to show my work this time. Add y, add 1y. And so on the left side, I have an xy plus 1y. And then I'm going to subtract 4x. I'm being super lazy. I don't want to like rewrite everything. Okay, so I subtract 4x to both sides. Now I have a negative 2 minus 4x. And I could have flipped those. Actually, it probably would have been nicer. But anyways, I'll leave them like that. Now, this is what you do. I'll bust up the red marker for this. Factor out the y.
Wait,
Yeah.
You added the y. Where did it go?
He's right there. He's right there.
Why would
I added 1y.
Why wouldn't it be 2?
Oh no, because I can't add that 1y to this term because it's an xy term. I just have a y term right here. So that's why. Does that make sense? Good question. Thank you. Okay, so I'm going to take out the y. That would get rid of the y there and make this one into a 1. And so if I clean it up, it would say y times x plus 1. And on the other side, I'm going to clean this up a little bit. I'm going to take out the negative and put the 4x first and then put the 2 second. Just because we usually like to put the x term first. And since they're both negative, I'm going to take out the negative. Okay, now you guys can probably finish it. How do I get the y alone? How?
Divide by x plus 1.
Divide by x plus 1. Now it's gone. We got to divide the other side by x plus 1. And so let's clean it up. Clean it up. Y equals negative 4x plus 2. Then on the denominator, I have x plus 1. And that negative can actually go in front. And then we won't have to write the parentheses anymore. So this is g inverse. If we plug x into g inverse, this is g inverse. Now, the tricky part is probably going to be typing this in. Okay, you can I think you can leave the negative up here with those guys if you wanted to, or you just put this in the parentheses and put the negative in front. But that's your answer. That is the inverse function. Okay, so this is what the inverse means. Let's plug in 1 because 1's easy. If I plug 1 into this function right here, it would be negative 1 minus 2 on top, and then 1 plus 4. What would I get? See, this would be like that, and this would be a 3, and this would be a 5. So we get a 3 over 5. When we plug in 1, we get a 3 over 5. Right? Okay, so now what about if I plug 3 over 5 in my inverse? What would happen? Does anybody know? No, it looks scary though. It's a fraction. I know, I probably should have tried to find a better number that wouldn't be ugly, but this is what I got. So let's just work with what I got. All right, so we plug in the 3 over 5 there, and now I'm going to have to plug in the 3 over 5 on the bottom, and let's see what we get. Oh, this is nasty. This is so disgusting. This is nasty, nasty. Okay, so 4 times 3, what's that going to be? 12, so I have 12 over 5, and then I have plus. Now, I'm not going to write 2 because I need to have common denominators. If I make the denominator into a 5, what would the 2 become? It would be a 10. So now we have plus 10 over 5. That's on my numerator. On the denominator, the 1, that one's easy. You just go 5 over 5. Okay, so we have 3 over 5 plus 5 over 5 is going to be 8 over 5. All right, still got some work to do. On the top, what do we get? We get 22 over 5. On the bottom, what do we get? We have 8 over 5. Okay, now it's kind of disgusting. We have a fraction divided by a fraction. Whenever you divide a fraction, though, that's the same as multiplying by the reciprocal. The reciprocal of 8 over 5. What's the reciprocal of 8 over 5? 5 over 8. And so we do our thing. We go, those cancel out, and I get 22 over 8. I'm thinking I made a mistake somewhere. I know this negative right here should be going through all this. I think I made a mistake. Do you guys see where I made a mistake? Nobody saw where I made a mistake?
There's so much work.
Because I'm supposed to get 1. I made a mistake, guys. I'm not getting 1. I should get 1. Let's see. Let's see. This is supposed to be negative. That's negative. Yeah, that's right. Okay, hold on. I got to see if I made... Wait, where does 4x come from? Oh, yeah, we subtracted it from that side. Is that true? Yeah, we subtracted that over here. So then we took out a negative. That's a 2. Okay, so far so good. I made a mistake somewhere. Let's see. Did I multiply right? What's 4 times 3? That's 12. Okay, so it'll be 12 over 5. And then 2. Yeah, that'd be 5 over 10. 10 over 5, that'd be 2. And so if I add those...
All I can see is your front.
Okay, no, that's good right there. Is this the right thing that I write down here? I get 8 over 5. Okay, there's a mistake somewhere. I know it. 8 over 5. All right. Maybe I got the wrong fraction up here.
Yeah.
Let's see. If I plug a 1... Oh, I said plus. Stupid. I have to go all the way back to change that. Oh, that's not good. This is supposed to be negative. Okay, so it's 1. Negative 1. Oh, wait. I see what happens. Okay, it's negative 1 plus negative 2. Right? If I plug a 1 into this, that'd be a negative 3 over 5. Ah, shoot. We plugged in the wrong the wrong number here. Okay, sorry guys. Oof. Sorry, yeah, that's right. I make mistakes too. Okay, so that's negative there, and this goes negative down here. That's going to change all these answers. So I'm going to erase these. Let's fix this. Sorry guys. Sorry. I'm so sick of this. No, sorry. Calm down. Don't put the chair down. Put the chair down. Okay. So the bottom's going to be 2 over 5. And then we have negative 12 plus 10. Oh, everything's looking a little bit prettier. No, it's still not pretty, Mr. Patey. Those are ugly. Oh, no, it's pretty. Check this out. You see how I got 2 over 5 over 2 over 5? Guys, what is 2 over 5 divided by 2 over 5?
Itself.
What?
1.
It's, oh no. Oh no. Oh no. Oh no. Oh no. Oh no. Okay, wait. This is negative right here. Negative, and this would be a negative, but there's a negative right here, which change, a negative and negative is a positive, so we can still get that. Okay, so when I plug negative 3 over 5 into my inverse function, I get 1. You see how these are exactly the opposite? That's the opposite. They switch spots. That's what makes an inverse function an inverse function.